Let me ask you something. Imagine asking your AI the same question twice. Why does it search the same documents all over again? It generates embeddings, searches the vector database, re-rank the results, filter the chunks, add citation again and again. That these are all the things that are happening for the same question which has been asked 5 minutes before, right? So this is not an intelligence, that is repetition. So welcome back to Building Enterprise Agentic AI System series. In this series, we are building a complete 9-layer reference architecture for enterprise AI agents. We are doing that one layer at a time. If you are new here, I would recommend watching the previous episode first because today's episode builds directly on the knowledge layer we created in episode 3. In the last episode, our agent learned how to retrieve trusted enterprise knowledge. It could generate embeddings, search ChromaDB, re-rank results, filter low confidence chunks, attach citations, and return grounded context back to the agent planner. It would exactly as designed, but there was one problem. It had no memory. So every request started from zero. Even if the same question arrived 5 minutes later, the entire pipeline executed all over again. In the real enterprise, this isn't inefficient. It increases latency, wastes compute, and makes every repeated query more expensive than it needs to be. That's exactly the problem we are going to solve today. Welcome to Layer 4, Agent Memory. So before we move on to a demo in our NexusIQ, most people think about memory as a cache where you add after the system works, something you bolt on later to make it faster. But that is a wrong mental model. In NexusIQ, memory is a gate inside the knowledge layer. It runs before ChromaDB is ever called. So the first thing I want to show you is where memory sits in the architecture, and this is the most important architectural decisions in this entire area. So let me run a complete pipeline so you will understand that. So I'll go through, I'll just take a new query. So I'll run through gateway and agent planner, which I don't want to go deep about all these two layers because we already had a separate video for all these two. So one thing I wanted to tell you, the gateway is all about, it provides authentication and authorization and checks policy engine it approved whether the query is okay to move forward. So if you see here, the decision is approved. So it passes the gateway and then it moves to agent planner. So agent planner does one of the important things is it decomposes the query into subtasks. It takes the query and based on the tool registry, it decomposes every task, and every task runs based on the tool required, and every output is being observed. For example, if there are three subtasks here: original revenue data, and the product trends and active pipeline deals. These are all three different tasks, and every task goes through the observation layer, right? So this is also done. So let's go to knowledge layer. So if you go to knowledge layer, if you see when I hit the retrieve knowledge layer, when I hit the retrieve knowledge layer, it goes directly to receive query and it goes directly to memory check before the general embedding model, right? If you see here, the memory miss. So since it is memory miss, the entire pipeline gets triggered. It receives a query, memory checks miss and generate embeddings, semantic search against ChromaDB, re-rank the results by relevance, quality filter, and add citation and everything which we saw in the previous episode. So there are 7 steps, and if you see here, there are somewhere around somewhere around 306 milliseconds, right? So there are 3 chunks retrieved. If you see here, chunk 1, chunk 2, and chunk 3, and and at step 8, you see something important like store is memory. So if you see here, store to memory. So the response is being stored under STM and LTM as well. So let's see what happened. What happened if I run the query again? Okay. So when I run again, it directly goes to memory hit, right? If you see that, there are 4 steps only. So the receive query and does the memory check. So it finds in short memory. There are 3 checks found. The ChromaDB will be skipped. So if you see here, the 306 milliseconds become only 2 milliseconds, right? So the agent remembered ChromDB was not called and the embedding was also not called, right? So if you see here at the end, the served from memory, the ChromDB was not called, same grounded context, same citations. So I want to show you something more powerful, the long-term memory. So we have been running the chunk analysis query across the entire series, right? Layer 1, it passed through the gateway. Layer 2, the agent planner decomposed it. Layer 3, the knowledge layer retrieved documents from it. So every single time the query ran, the knowledge layer did the same retrieval work, same embedding, same ChromaDB search, same chunks written. The agent had no memory that it had done this before. So now I'm going to switch to the long-term memory scenario. The chunk query is preloaded, right? This is the exact query that has been running across the entire series. Let's see what happened. So I'll go to gateway and I'll replace this. So it is approved and I'm moving to planner and I'll start planning. Yeah. So I'll move to continue to knowledge layer. So in knowledge layer there is analyst, so the same query came in. So if you see here, the knowledge layer was bypassed entirely, right? Not just ChromaDB. The entire retrieval pipeline, the agent found this query in long-term memory from the previous session and served it directly. Look at the right panel, 208 milliseconds become 4 milliseconds. Same Q2 channel analysis report if you see here, same and Q2 original sales performance and again served from memory. The ChromaDB was not called, same grounded context, same thing. So there are no retrieval cost, right? The retrieval cost is 0. This is what an agent that learns look like. So continue to memory dashboard, right? Let's see what is happening here. I'll just refresh here. It's getting loaded because I just break the flow, so it's got loaded. So if you see here, there are two numbers at the top, short-term entries and the long-term entries, right? Right now I have both entries. The short-term memory expires after 30 minutes. It handles within session repetition. The same question asked twice in one conversation. Second answer is instant. So long-term memory persists across sessions. It never expires. It grows over time as the agent learns the recurring query patterns of the people using it. Now the important question is, where does this actually live? So both types are stored in SQLite in a file called an NexusIQ memory. It is not a DB. So SQLite is the right choice here because it's a file based with zero infrastructure dependency. So there is no Redis server, no separate process, nothing to configure. It persists across restarts, and for the query volumes, a single enterprise agent handles, like I think it is fast enough. A memory read takes under 1 milliseconds, right? So if you see here, there are 280 milliseconds have been saved across all sessions. So in production at scale, you may swap SQLite to Redis for short term and Postgres for a long term. The interface stays the same. The rest of the system never needs to know what changed underneath. So if you see the audit trial as usual, the audit trial at the bottom shows every memory event, hit or miss, right? If you see here, and which type, how much time was saved, and you can see 400 tokens and 306 millisecond original, and you get all these things. Yeah. So in the governed enterprise system, the data trail is not just a monitoring convenience; it is evidence that the system is working as designed. So, let me step back and explain why the architecture decision here matters. The planner does not know or care whether the context came from memory or from a ChromaDB. It just receives grounded, cited context either way. That is the point. Memory is transparent to the layers above it. The gateway approved the knowledge tool. The planner dispatched the call. Memory sits inside the call, not outside it. And when memory serves a hit, the planner receives exactly the same grounded context it would have received from the full retrieval. Same chunks, same citations, same page numbers. The planner synthesizes the same way regardless of which path was taken. So there are four layers, one query, each layer doing exactly one job. The gateway decided whether, the planner decided how, the knowledge layer grounded the answer, the memory layer made the agent stop repeating work it already did. Right? So let's step back and look at what we have built so far. We have now followed the same chunk analysis query through four different architectural layers. The AI gateway decided whether the request was allowed. The agent planner decided how to solve it. The enterprise knowledge layer retrieved trusted enterprise information. And today, the memory layer taught the agent how to stop repeating work it had already done. The important thing here isn't the response becomes faster. The important thing is that architecture becomes smarter. Instead of paying for the same retrieval over and over again, the agent can now recognize previous work and reuse grounded context whether it is appropriate. That's the fundamental shift in how enterprise AI systems are designed. But even now, our agent still has one major limitation. It can reason, it can retrieve knowledge, it can remember, but it still cannot actually do anything, right? In layer, we saw you saw the agent planner invoke three different tools: SQL layer, knowledge layer, and CRM. We have already explored what happens inside the knowledge layer in episode 3 and 4. In the next episode, we are going inside the SQL tool, right? You will see a real MCP server, real SQL generated by the agent, a real execution against a live database, and real results flowing back into the planning process. That's where enterprise AI stops answering questions and starts performing real work. I'll see you in episode 5.